My name is Daniel Cziczo. I'm a professor of atmospheric chemistry at Purdue University. My group and I participated in a NASA field study called Dynamics and Chemistry of the Summer Stratosphere, or DCOTS for short. We used a NASA high-altitude research aircraft called an ER-2 to investigate the upper troposphere, our part of the atmosphere, and the lower stratosphere, the next layer up of the atmosphere, during the summertime. We did this over the US Midwest because of the big thunderstorms that we have in the Midwest every summertime. And what we were particularly interested in is how those thunderstorms affect the stratosphere, the next layer up of the atmosphere. One of the really interesting things that we found as a part of this study was that biomass burning, basically wildfire smoke from the lower atmosphere, was making its way, because of these storms, into the stratosphere, and basically adding wildfire smoke to this next layer up of the atmosphere where we didn't think it would occur. So as our climate changes, as our climate warms, the surface becomes warmer, but it also becomes drier. And often what this leads to is an increase in wildfires. So there's an increased prevalence in wildfires, but there's also an increase in the amount of area that's burned every year. So we normally think of that smoke being trapped somewhat close to the surface, and those in the Midwest have seen this smoke come in from, for example, the Canadian wildfires over the last few years. But when you have these powerful thunderstorms, they can actually act essentially like an escalator. They can take some of this material and move it from the surface up to the upper part of our troposphere, but also punch it into the next layer up, the stratosphere. So people probably remember 20 years ago the ozone hole, and that is a phenomenon that takes place in the stratosphere. So our stratosphere contains an ozone layer, and this protects us from what we call the short-wave radiation from the sun. Essentially the stuff that would cause a very severe sunburn and ultimately things like skin cancer. Ozone essentially filters out, it absorbs that material before it can make it to the surface. So we think of the stratosphere first and foremost as the location where this ozone is. And so when we perceive changes to this layer of the atmosphere, we immediately become worried about the ozone layer. And could those particles, could those gases perturb the balance of ozone? So that's one of the things that we're very interested in, seeing this smoke make it into the stratosphere. Another thing is that smoke, as everybody can think of, is a dark material. It can absorb sunlight on its way in. And again, the stratosphere is very pristine. It has very few particles, very small particles, typically clear material like sulfuric acid and water. So adding this new material there, especially a dark absorbing material, can perturb the radiative balance. It can perturb the climate of the stratosphere. It might heat it up in ways that are unexpected and can change things like the dynamics, the circulation of the stratosphere. So this is another thing that we're interested in right now. Finally, we're also interested in just the overall balance of the stratosphere. And if we see things like storms starting to perturb the stratosphere, starting to make their way into the stratosphere in a way that didn't happen before climate started to change, that's worrying to us because it would mean that the stratosphere could behave differently moving into the future. And we really need to understand that before it takes place. So the way that we did this work was that we put a number of instruments on a NASA ER-2, essentially a high-altitude research aircraft based on the U-2 aircraft, which many people have probably heard about. So the instrument behind me is our particle analysis by laser mass spectrometry, or PALMS instrument. So this instrument is able to pick out particles, one particle at a time. We strike those particles with a laser, which allows us to break it into its components so we can tell you what the chemical composition of those particles are. So by flying this on this NASA high-altitude research aircraft, we're able to get essentially an understanding of what the particulate matter is in the stratosphere. So once the plane comes back, we're able to open up the nose of the plane, pull the instrument out, grab a small thumb drive off of it, and then go into the laboratory and figure out what those particles looked like.
I got this. Take this side. You want this side warm? Oh.
Hang on, I don't want to bash into that. Does it look, Justin?
You good?
Yeah, it's good.
Okay.
Good to you.
Okay, we can go a bit. Okay, wait a minute. Hang on. We're going to go just to the last tire, and then Justin will do one final check, okay?